exclamation marks, no question marks when it comes to types. That means we also remove this syntax that was on trial for variable sized arrays, and here we get that. And there's a new fault declaration. We changed the faults of the faults. So these are like big changes, really, in terms of, well, they are really changing a lot, but it's not really changing the semantics of the language. And recently, most recently, there was a change from def to alias. So to kind of we could kind of look at some old stuff, I guess. But okay, let's not do that. Let's assume that you already know about this. So you know that the old syntax for defining stuff was like this. We have distinct. It's going to give you errors now, like this, and then making some general alias like some function. It was going to be original, right? Function, like that. And then finally creating new attributes. So my attribute was like this. So hang on, it's wait line. We can make them parameterized. Actually, that's an important thing, and I'll get to that later. And we have the faults. So now the faults are. Before it was like fault, some fault, and then we kind of defined inside of that ABC. That was a fault. Oh, the IDE crashed on that. Okay, that's fun. So it would look like that. But recently, the change of faults to kind of be values turned it into like some fault instead, like that. Let's create an error up here so we don't get these underlines, which are kind of annoying. So then the next change, the recent one, was doing this. So now we still have the distinct, we have the fault, and now it's kind of look cleaned up, but there are things I don't like about this. So we'll talk about that. Sorry about that. I really had sneeze. Okay, let's see. Okay, hello everyone. So I see that Ivan and Tuchimo is online. Do ask me questions and do bring feedback as I speak here. So what I've done some preparation for this. As you see, this should have been working, but we get errors here. So maybe I should bring back the old highlighter. But the main problem with this, let me do it like this. So these are fine, I think. Mostly, there's one thing, like these are aliases, plain and simple. This is not making a new type, for example. It's just like turning foo as an alias for int. And you would typically do that by then also saying like if it's let's do this if something is true, then it's an int. If it's something else for some other reason, then it's a short, for example. And you can do that to kind of make conditional. One type is for, well, you can show example. So we go to libc here. So for example, here we have the struct, which has two, like this only exists if the environment is not within 32. Then we have a bunch of these kind of things. So you can switch depending on, like here we have the function and it's there or not there depending on if what operating system we are on. So in our case, that's the reason why you have alias, so you can like have the same name but have different underlying types. And you get the same thing for in the case of aliasing a function. I think there might be examples for that as well. Something with the win, like there's some places here. Let me try to get those alias. Okay, that one is not a good example, but where we get like seek index is c long. Okay, we see here that we get different aliases depending on again, that's what I talked about, like depending on what platform we're on. Okay, yeah, and then we can do the same thing actually for the functions. And we can even do that differently for variables. But here we have something else. Okay, so we have the attributes, and this is because in C you can create kind of these made up attributes using define. We can define anything, my attribute, which then would kind of have like inline and attribute and so on stuff with that actually takes a parameter, but these parameters are just text replacement. So but in C3 we can't do text replacement, so we actually have to have a full-blown feature here. And this is actually, I think there's a semicolon there. And this is kind of weird syntax here, and that has to do with how this is parsed. We might be able to get rid of that, but I'll talk about that later. So this is kind of this one here. Like this one is really the odd man out here of the aliases. So the other ones make sense. So the alias of foo equals int, these are quite fine. These are functions or again, this could be a global. So it could be a constant, like my const equals that const. That would be fine too. So it's just a name replacement here. Let me see if there's any questions for. So no, okay. So then we're having these new faults. So the problem is that we currently have like if I create any fault, you want to like do like store it in a global, in my global here, and I want to store that actual value like this. I have to use this name, any fault. That's like the name, and that made sense back when any fault was a union of all the different fault types, because a fault was then a user-defined type, but now it's just a constant. So it doesn't make sense that it's called any fault anymore. So it should be called fault, which creates the problem, like you can't really say these are equivalent. And while it could perhaps figure it out, it's not a great thing. So I was like thinking, okay, maybe faults, some faults, some other fault, right? And then we have this as a type, and that works kind of. But I don't like faults. That seems so weird. That seems so really weird. We also have the distinct, and that we didn't change before. So it used to be like def. I mean, that was the way you define things. So if you had this, that would be an alias. But if you wanted the distinct one, you would do like this. And that didn't, like that worked for a while, but not later. So now it's like distinct. So we have these, and these are kind of problematic. So one thing I was trying then, I don't know about this, but it's like an attempt to kind of find something. So you see, this kind of pass. I did change this. So while we could keep distinct, we could also try typedef, which will mean something different from C, where C, that's the same as alias, right? But here we can say, okay, so let's define a new type. So it's essentially distinct. Same as distinct foo. That is, we create a new type, which is foo, which isn't int, it's a new foo type. And then we can extend that kind of idea. So let's do fault def. Now we create some faults. And then finally, because the attributes are not really real attributes, like they are sorry, the aliases, they are attributes which actually work differently, because no of the aliases, they're name replacements, like name aliases, and this isn't. This is definitely not. It's like a group. You define a new attribute which consists of these. So the idea would be like basically, if you look at it, what happens is that distinct, like this means like distinct is gone. This means, any fault goes away. And this one is like the addition, where we add this. So there's just a net addition of keywords here. But this is not super great. One of the arguments against it is like typedef has a very overloaded meaning when it just becomes something else compared to C. But it has different syntax, slightly different syntax. As you perhaps remember, the actual order in C is like this, which I totally, I always forget. Like, I have to remember, I have to put in a struct here, and then like, where goes the struct? Yeah, it's there. So that's where it actually be, yeah. That's how I remember it. But this one has an equals sign, so it's different. There's also one more thing. In C3, the arrays don't become pointers implicitly. So that kind of thing is kind of similar to how typedef basically just replaces it with basically works on the alias. And if we can change the arrays without changing the syntax towards C, maybe we can change typedef. At least we will get like the symmetry with type, with fault, with attr, and all of them means like let's define something new. That is actually, and the nice thing is like you could have several. Also, like a comma is not a problem here for multiple faults. If it says just fault, it looks really odd, like fault, some fault, and then comma, something else. It doesn't feel good. I've tried other ways, like these, like const fault, some fault. Looks weird. Even fault const, you can like this, like that. But this is such a common thing. It's like people will not understand what that means. If there's like fault def, I can feel that they might understand what that means. And we have the alias for everything that's like that's actually an alias, which these aren't. We have that. So let's look at what it looks like. So I think we did some changes here. Actually, something is not. There's something. Yeah, this is this one. It complains about that one. Let's see if we can jump somewhere where that isn't the case. Okay, so here we get like the typical D string where I changed to typedef. So before this was distinct here, right? So this is distinct D string, and those become typedefs. Let's see if we have something else here. Maybe not. We got the we got something else here, right? So let's see what that was. I have to look in a different. Yeah, so we have again we have in this case I think we have the definition of faults. Fault def, no. Fault def. Yeah. So here we have going from fault to fault def. Kind of looks okay. I had some other example. Where was that? Where you could kind of see something else about how this thing would change the code. Maybe I can search for it. So I'm going to search for a distinct. There are still a few places where we have distinct. For example, here. So we got this, and then dipc allocator. We're just going to do like typedef, and that's it. There. We got that. Okay. It's the suggestions here that actually aren't quite correct. Okay, and let's see if we can find some example of something else. We have the maybe let's see some alias. Right, so here's another one. So we have core foundation, which is a part where some of the Mac OS Objective-C frameworks are described. So instead we get for distinct, we get a typedef, and then we get an alias. So we can, this is why we will look and can read that. So you can just get like, okay, typedef, that's something distinct, and here we just got an alias. So you'll get when we see a CF index, that's actually ISIS. ISIS. Okay, so let's see what you think about that. Okay, now we get a question. So what about new type? New type foo. New type fault after well, likely, yeah. So what, I'm sure what new type foo equals in. Yeah, of course we could add completely new keywords. That's possible. Hang on. I like falter after typedef. Yeah. So yeah, I mean it's not an obvious thing that this is good. Absolutely not. That's why I am testing. So the way I test is typically like this. And so in this particular case, I would I grab the IntelliJ actually plugin and then set up the new syntax for it. So that's what I've done. That's why it looks like this, right? So I mean, yeah, the typedef. I mean, on one hand, yes, it's not good that typedef is reused, but it also looks great. for seeing that finally, kind of, I don't know. It's maybe I should remove it just because of that, because I like it. You know, and never add something you like. So that my that's my I guess that's my philosophy. Don't add stuff you like. Just add stuff you need. But it's super easy to. I mean, I would like to have that. It does feel all right, but I don't know if it feels if it's right. But it might be okay. Otherwise, we'd have to try something else. So yes, we could try like anything goes basically. But that's the problem, because then you like if you start by saying like it could be anything, then we're off the charts. We can just do anything. So if we say we need to have, in order to get some kind of logic to language. There has to be some kind of underlying principle to how you select names and keywords and so on. Now, one way that might seem inconsistent, that gives somewhat inconsistent results, is to use what others already used. And that's perfectly fine, I would say. It's not. It gives a somewhat inconsistent naming, but people will know because they are familiar with something else, right? You can call something, Goto, uh, go to, yeah, go to, um, and even though that name might not be in line with everything else you have, people will know what go to means, right? From other languages. Or a for. I mean, that name is like, yeah, it doesn't really make sense, but you know it from all the other languages. It's just something, even if your language is the first one people encounter it, they will use that name in the future. So how does that relate to these designs? Well, in the case of alias, that's used in some languages. It's most of all, it's actually used in D. Maybe not there might not be a lot of people coming from D and learn D and then go to C3, but I find that D has a good sense of naming. It's not like C++ where the naming is like totally atrocious. It's like using. I understand, like, do this using this fact or something, but it's just such a poor name, really. And other things in other languages. Anyway, so okay, let's talk about like the other way to do it. The other way to do is to have some consistent way to derive names, right? So, if, for example, a common way is like new types, right? We want to have new types. So people come up with, I32, I16, and so on. That has a logic to it because you know what the pattern is, and then you know what the next one is. You don't have to like figure it out. So you have either you go for what's already well known. It's like you have an int, people know int is a type, or you go with, and that's using previous languages, the familiarity from previous languages. Sorry, it's when it's late. I have to. You want sometimes. Oh yeah. Anyway, uh, or you go with a new naming, and the new naming then has to like kind of stick together so that you from one name you can kind of guess what the other names are going to be. And this is something you tend to do a lot in standard libraries, where you kind of decide what do we usually call something that converts something to something else. It's like, is it to blah blah blah, or is it as, or is it, and then use that kind of consistently, whatever the name is. Okay, but back to the question here. So the reason I didn't start with typedef, I started with faultdef, right? And if we have faultdef and we have alias, all of these like distinct, blah blah blah, and then we have the same alias for attributes, then that looks very weird. So like this. This looks weird because now we introduce a new naming, which is like fault plus def, right? And that's defining a fault, right? But we're now defining a new attribute, so you should really name this one attribute def or attribute def, but that's too long. So that should be it. And then we like distinct, but distinct is creating a type, a new type. So the logic would then be, okay, if we're creating a new type, we're defining a new type, then that should be typedef. And so that kind of is the logic between for using all of these. And by the way, the reason why it was before was like I had this def foo equals int. It's because I wanted to generalize typedef. So typedef just works for types. So but I want to use that as a common alias thing. So then it was just def, which also is like define foo int that also existed. So it was kind of using that idea. So that's why we ended up with this possibility. Just wanted to show you that. And I actually updated some, as you see, I updated some things here to have this new thing. So here we end up, by the way, here, this one is a nice example, I think. So we could compare these, like if you think about what this used to be, it was then, let me just grab the old one. 1 second. I know you don't see this because it's on the other screen, so but I'll just grab that from here. So we have, oh, maybe you could just have it twice. Right, so the distinct version, here's the distinct version, which looks like this, right? And distinct, and alias, and then we have the fault. And here we can compare with typedef instead, and then alias, and then fault def. And to me, this typedef is kind of nice. It kind of complements this nicely. So the alias and typedef, they kind of balance each other out. And kind of like, okay, there's a typedef, and then sometimes there's an alias, and they have to be different. So obviously, if there's a way to alias a type, then the typedef is doing something else. So that's what I felt. Okay, anyway, let me see what you're writing. If you're using a name but it's not the same, it's like a false friend, it will annoy people. Yeah, I mean, yeah, that will happen. I like Distinct doesn't have much that it should though. So like ignoring the syntactical difference between what you're doing are semantic differences. It's just that that doesn't in C3 as distinct. Okay, so I relay them. So okay, so just to explain what distinct does, I can maybe I think some things will break if I just demonstrate some of this. I think where I'm breaking things because I changed some order. So let's see what happens if I just call this and run. I think there was a bunch of errors here. Typedef. Type name was okay. Yeah, I think. What? Okay, let me shelf this, or otherwise it's gonna be super confusing. I'm just going to do whatever. What? Oh wait, I didn't even implement typedef. Yes. Right. Okay, let's shelve this. And now it's there and doesn't look like anything. And I have to grab the old plugin. Maybe I don't have to do that. I'm just going to show this. So if I have a distinct type, so I'm just going to use normal syntax. So what happens is this. If I try, I can do this, right? Let's create an alias as well. So the alias foo is also foo2, isn't it? So if I try and have an int here, by the way, we can have like that, and we have foo2. Where is it? G here. So it's also 3. So I can do f equals to 3. That's fine. But I can do g equals to I. But if I try to do that, right? If I try to do this, I will get. Sorry, that was something I had tracing, so it's not a bug Okay, so we go here. So we see here we get this error here. Implicit casting int to foo is not permitted. And the other way around also. So if I do like this, you're not allowed to cast foo to int. But for G, for this foo2, that's completely fine. And we can do literals are fine. They automatically convert, so this would be fine. For example, oh, let me remove that row. So it's still kind of okay. That finished. Yes, good. What happened to the? Okay. No output. And let's see if I just have the settings here. Some weird settings here. Is it running everything? Yeah, should be running it. Okay, so we have F here. That works. And I can have this, so I can say it's inline, in which case this works. So I can convert a foo to an int. That works, like an alias. But if I do it the other way around, try to assign an int to a foo, then we get an error. And this is kind of useful for a string, for example. A string is not like you can't take a string is basically this. String is a char slice like that. But it's actually an inline char slice. So inline. That means that any function that takes a char slice can take a string, but if it takes a string, it can't take a char slice. So if it had been like an alias, so just been like string is char, then none of the code would have known this is a string. And this is used for example in a formatter. So if you print something and it sees, yeah, this is a distinct string type, then it can print it as a string. If it just sees a char slice, it assumes that this is any bytes. So this distinct thing is like really useful. You can put different methods on the distinct types compared to I mean, they are different from the original types. But if you have an alias, then it's just the same, a different name for the same type. Okay, so let's see if that was clear enough. So okay, can I add? Yeah, so let's see here. Okay, so there's a can add methods not distinct type and so on. Yes. So I could I could use this thing to stop integer back enums from silent and convert into another. Yes. So one of the tricks you can do for enums, like you might model something. You have in C, it might look like you have this enum foo, which is like ABC, which is 42, and df, which is minus 7, like this, right? And then you have a function which looks like use foo, and it takes it's supposed to take a foo, right? And then you want to translate this part into C3. And so, okay, that's bad. So you can't use the enums in C3. So you come up with the idea, let's use inline. Inline int value, right? And then we can do ABC equals 42 and df is minus 777, like that. And then, but then was like, okay, so now what should I do? Now I just have the use foo and it takes an int then, right? Like this. But now I lose the ability to, like before I could do, like in C, I could just have this, and then I would have to use this rather than just someone putting in this, right? So this would be an error. That's what I want. Like, how do I get this? If we have this example here, we can see that it just compiles for all of it. It might not link, but so let's see. Type name was yeah. Sorry, I forgot the void there. So we kind of, yeah, it works. But what we can do then is like let's introduce a distinct foo value, which is just an int. It will like behave, lowering and so on will be a foo value. So it will be an int. So then we do like this, and then we say it has take a foo value. And now we try the same thing. Let's compile that. Oh, wait. Okay, there's one problem with this. Sorry. There's one problem with this. It's because a foo value can automatically take this constant. So let me show this by having this instead. Sorry. Okay, and I'll show you that it worked. It just happens to be, it doesn't work for that particular case. Or something. So here we can't cast this, but if we had int instead, like before, like this, it would work. So you can put in whatever you want. There might be something that you could, need to do a cast here as well. That's possible, but most of the time you don't want that. So it's I don't know if that's how useful it is. Like if someone actually puts in a for where there should be an enum. It's more common that people just have something which is an int and then try to put it here because they're calling like multiple arguments, and then it should be a foo if there or something. Okay, was that a? Let's see if I opened the wrong thing here. Was that? Hopefully that was an answer to Twitchy Mulder. Put in the wrong enum types. Yeah, you can. In this case, you can make a new one for every enum you have. Yeah, good. Okay, so that already exists, right? So this is more like what we're talking about, but going back to what I talked about with these changes is that this is like syntax tweaks, basically. Trying to get it more kind of memory friendly, if that makes sense. More easy to recall. And something I've been thinking about as well is like trying to make the language kind of easier to get into, even if you haven't used C. So it's C is a very good constraint, and trying to attract people who want to use C is like the right thing for the language. But that said, there are things in C which are confusing to people who haven't used C. So retaining them just adds confusion to people who haven't used C. It's like not about semantics, just like some syntactic stuff. So we already removed some syntactic stuff because these are common pitfalls, and people never remember features like how the like a spiral rule works and so on. But also in thinking about the keywords, I like typedef, but will people outside of C recall typedef? Will they like think that that's a good name, or will it like just think that that's a weird name? That's also actually that's even though like the argument against typedef is it's going to do different things from C. I think another argument against typedef is this might be something that people not used to C will think like, oh, it's a weird name, you know. That's a weird name. But we are going to have to teach people distinct anyway, because distinct doesn't say what it is. Like if you know what distinct, if you know that it's kind of there's something called type names, you can create types in some way, and there's like something concept called distinct, then that makes sense. But a lot of people actually think that typedef is creating a new type. I encounter that people come to see or sometimes think that they actually have a new type when you do typedef. It does seem like that. I mean, you have like, let's define a new type, but it isn't a new type. It's that's like the false friend here is like really C, which is kind of calling it that even though it's an alias. So I don't know. So if there is some more, you know, another name for creating distinct types that is in use, that would be nice. I mean, there is the common thing that you can just have type and then you define something like this, right? So, but that just works for types, and then we're stuck with, okay, how do you call? Like then we just here with false anyway, and we have this, which is a very nice name, a nice variable name or function name. So we kind of hog that one. Whereas no one will kind of use typedef as a variable name. So faultdef also is like, this is like a free keyword that no one will really use for a variable, right? And not even for a function. So those are very nice things to kind of use. It's not, I mean, using type is not as nice, just because it's like that's something people will use. False, like this, is also something people will might use, like how many false, or a list of false. You know, they will call that false. So it's not very nice to grab those names. That's why things are like called name of. Like, why do you call name of? Why not name? Well, it's because we're stealing the name, like we're hogging that name for the compiler, so, or the language, so then people can't use it, and then we try to use something that is not very valuable to the user, basically. Let's see if someone has any comments here. That's like kind of, yeah. So let's, okay, so let's see here. The integer types are hard if you have never used C. You're thinking about like what for I32 is better and so on. I think that's worse. I think that is like, okay, let's throw people into the into the deep water and like hope they swim, because suddenly you have to think about like what is, the bit sizes of things, the what's that, I don't think that's very user friendly. Actually, it's like makes sense for Rust to kind of throw people in there, and then people like, oh, we're used to Rust, and Rust same are so awesome. Let's have these I32 and so on. But I'm no. Um, we have in with Java you fixed those names. In C sharp you fixed those names. If you come from C sharp or Java, you will like totally not be bothered by it's not being I32 or such a name. So it's like it depends very much where you come from. So I don't think the names are going to be a problem unless you kind of I want those names. I can't live without it being those whatever I prefer. And I mean, it's kind of not so nice that C3 is not able to offer people to use these aliases for I32 and so on, the popular names. It's definitely nothing I would have preferred to kind of block. But now the naming rules have to be a special some way. You know, we can have all uppercase for types. We can have a trading T for types. We can have types all lower, I guess all lowercase, or like the identifiers now. So like lowercase, starting lowercase basically. Um, and then finally the what's the current one, which is kind of something like Pascal case. But that will also mean like as soon as you get like, oh, you can type I32 and have that for the types, but then that means that all your variable names will have to be like all uppercase or Pascal case. And I don't think people want that. I wouldn't want that. That would be horrible. Um, a fault def is a bit awkward. It works, but new fault is probably better. New type is probably better than type def new. I never see new type. Um, I never seen that in any language. You're saying like this. So new type. I mean, nothing is wrong. New fault. There is a problem though. It's not bad. It's not a bad idea. MC, but new is typically associated with allocating something in memory. So I that doesn't look common. It looks a bit alien to me, basically. Um, I prefer things to borrow from other languages, and using type like someone again suggested doing type like this. And yes, that's fine. I mean, maybe people don't know, but this is how structs are defined in C2, which goes really all in on types because it's like everything, all definitions start with type and a name, which is great because then you can grep for this. So it's not bad at all, but I found that this just feels too for me at least it feels just too unsee like it just glitches too much compared to just struct foo. And also the placement of the attributes then has to be like down here and um, line something like this here and kind of floats or in here, which is yeah it ends up being not great. But otherwise, like type would be okay. But we're not really the type. The distinct thing is like it's kind of okay. It's like typedef is just a a um a consequence of picking fault def. And here's like the fault. This is the problem. So fault, you can claim that everything else is good, but foo fault here. Let's have that. That one is okay for me. Fault isn't working. Like it is definitely not working. I've looked at that in with a lot of code, and it's just lacking. It's not just that this. It's like you can't really define multiple things and feel that is. That looks good. Fault, it just says that there's a single fault. Also, it's like kind of begging that you define something else with this. It doesn't feel like you have a list of a lot of faults. It feels like you're here, we're going to define something. That's why the work looks like everything else, like struct, it has this exact structure, right? So it says struct, and then it has a name, something, and then we have this. That's how it works. Now the name is from the name you can gather that it's not that, but it's not still not like it just doesn't sound right. False would be like the only thing that kind of would look like that in the language. And again, it's not like easy to derive that knowledge what it should be from knowing anything else about language. Like even knowing about the fault, that there exists something called a fault, you can't derive the knowledge that it should be called faults from anything. Well, we had def before. It could have been like def fault, but again, this is kind of really long and awkward, and nothing else does that. So, well, like, why have two? And if we have def fault, and we had tried to like, maybe someone like, okay, let's fault def, and yeah, then we end with that, and with that one. That's like the what you end up with eventually. Otherwise, you have to call it something else. When we're talking about excuse, so excuse, but it's so long. And that's the problem. It's long and not well defined, and people will not understand that. Faulty still don't understand, but it's somewhat better. Okay, let's see if someone wrote something. Okay. I kind of like the type without a def. Sharp has it as a keyword, and it's not that big a deal. It's okay. Int a b assign. I'll go with something similar to foo struct, and it's kind of type foo struct is kind of a bit annoying. I think the typedef and faultdef is good. Anyway, so I'm not sure that this will where this will end up and like what it will be, but I just want to share my thoughts about this and explain what I do in order to kind of evaluate this. I don't think, I mean, these things, even if I like just search for, I reverted the standard library here, so I could just search for something like distinct in the standard library, and I get like, I do get hits. What are they, like 122 hits on distinct? So these would be like maybe typedef or whatever. It doesn't matter what it is. Right, so that affects that many. If we look at faults, we have the fault. So I can also find fault, the definitions of those. So we have actually fewer. We have, what was that, 18 places where fault is used. And attributes are like, it isn't used at all, basically. So we have, I can just grab that. Let's see here. So regex there. Let's see if I can find anything. no, I don't think there is like anything which actually, like in the standard library, nothing is using the attributes. So we have the alias, which is kind of unchanged. Basically, the aliases are unchanged, so we're only really changing with the distinct and the fault definition. So and whatever is going to be affected most is the distinct the distinct stuff. So again, we can kind of look at what this would be. It would be like the fault def, right? Um, I don't know. Again, here, fault not found, or it defines a fault. And here, we can see it. Okay, it defines a whatever there. So that's a possibility. But this is like the last thing that I'm going to change. I just need to fix this fault because we really need to remove any fault. So the any fault name has to go. That's like it starts with I want to change any fault, and it ends with let's have typedef again. But that's the way things happen, really. It's kind of this like you hit one billiard ball, and then all the others are moving around after that. Functionality wise, I've been testing things like for example, I did start implementing this like this. So in this case, you would not need to, you kind of, what was that? Okay, so I did like this, so that, oh, sorry, here, like this. So it basically, this one, inline foo a, would actually take an int, but it would not take any literal or anything. It has to be like the type foo, and it's translated when you make the call. But as I implemented that, it was so useless. So it wasn't worth adding that complexity and that weird semantics for that. So we're kind of done in a lot of ways with 0.7, I think. There are things that we should be exploring for the future, though. During 0.7, aside from obviously the standard library, the standard library has been somewhat standardized, but there is something. Let's see if I can find that. Obviously, the ASM is not good. There are bugs in that, and I have to just sit down and just do the ASM from going through that again, and I feel bad all the time because I haven't sat down and really done that. Okay, I don't know if there was any change. I can maybe just address the idea that false should carry values. It's been a common thing that people want, and I can understand that's super useful and nice. It's just not possible. to explain why, it works like this. So if I return an error or something, return an IO like this, for example, like this. This actually just returns the error code here. So underlying type is actually a pointer sized thing that's getting returned when I call foo. Like this. So where would we put additional information? So people might think, okay, let's do it like this, right? So let's put in some data, but where do we put that? Okay, so let's say we put that in some additional information, but now there's just a void, star here, pointer that's returned. So where do we put that? I can't put it in the in the call, because we're doing things like where do we store that information? Like, where is that? There is no place we can possibly store that information, since we're just returning the pointer, which is, and the pointer itself is just, that is the ID of the UF, so we don't have any space. We put some information on the like possibly when we do the throw, we can put some information on the thread local storage. But then there's this. Okay, so let's say I have bar, and its first is calling foo and getting a f and getting an error from there. And let's say this thing then, this places this information from here, from foo, into the thread local. And then we have some other thing, and it's also calling foo, and it's placing that information on the thread local, on the same thread local, obviously, because it's just like one place. And now we return f. So, and then the calling method might want that information, but how? How does it know it's f? Because we just overwrote the information from f when we got g, right? So this is not available. And okay, let's say, oh, but then let's allocate memory for f separately or something. But also that is a problem, because, well, how much storage do you want, and like how big should that be? So it's just not a good idea to kind of fiddle with that and try to grab any sort of memory, place some sort of memory in there. What actually works is like having a struct called details, which you have like string x and some code and so on. And then what you do is that you pass it along, like this. And if it's like, for some reason, if in this case, then we write some information to details, right? Maybe details code could be 3, and then we return IOEO5. Right, it's like that. And then we come to bar, and then it has the details A, right? And we have details B, and we maybe get some details here too. Details C, and then pass B, and then we decide for some reason that we want if something, then we return f. So then we get like c equals a, return f. Otherwise, we have like c equals b, return g, and so on. So this method always works. And so that's it's a way to do it that actually works, and is will handle any kind of problem you'll run into. But it's not very nice, but it is possible. Because you decide also how big this detail is going to be. And then you can, have to manually manage to pass this around, but there is just extra cost if you know that you want that thing. So this kind of swap here, that's what makes it. That's the problem. It was just try catch, like normal exceptions. You can't do these things, like these swapping things. So then it's very easy to store that information because you just have one path, really. But you don't have one path in the sense that you can jump out of a lot of places, but you have you don't need to restore. Well, you can actually do that depending on the system. Sometimes you can store an exception and throw it later, but not having that ability would make this simpler. Like if you had a try catch, but you couldn't store and rethrow things. Anyway, but if you have exceptions, then you probably have a lot of other problems, and you can probably put the exception itself can have whatever data you want. But that said, I mean, I've used Java a lot, and the only places where people actually used the exceptions to supply any data, all those cases were broken. That's never a good idea. Okay, maybe I should wrap this up. Well, let's see if there are any questions here. So, okay, we have an index default as a unique value that can then be associated with that fault, associated with some value. I'm not sure. I mean, it's possible. It's definitely possible to like have say something like, okay, we have a fault. Let's say fault f, foo fault, and then it has some data that you always define or something. It could definitely work like that, but that would mean that these fields were always the only meaningful thing would be like if you would access things like you have a fault f, which you don't know what it is, and then you just kind of whatever you can define here. Maybe you have like, okay, int code equals, I don't know, let's say code is 3 and name as something. Then maybe you could have like, okay, let's get the code for it without knowing what it is. Let's get the name for it without knowing what it is. Those are useful things. What is not useful is like if f equals foo fault, then get some custom things that are just in this particular thing that is a foo fault. That's not useful because then you can just get this directly normally. So you want to, it's just for generic work. Yeah. Ooh, okay, so for someone trying, for someone trying to keep up to date with C3, what would you advise? Stick with the latest version, latest release, or try to keep up to date the master branch on GitHub? So currently, because I'm just experimenting with syntax right now, people will have a bad time using master and the latest release. That's not usually the case. It's not been the case during 0.6.8 development or anything in 0.60 after like from 0.6.0 was released, because then it's always backwards compatible and you can just grab the latest and it won't break anything for you. But now everything is getting broken because I'm breaking a lot of things, a lot of rules, and a lot of syntax in zero. Not so many rules, but syntax is breaking in 0.7. So, and I'm still breaking it. With this thing is gonna break the last parts. So right now, for like, was it? This 14th of March, and the launch is scheduled for April 1st. So maybe I'll give this about like a week or so before I really make a decision on what it should be. Um, Maybe I'll try. I'll commit something. I'll try something and then revert that. So if you want to try it out as it's like wildly changing, you can do that. But if you want to build something, absolutely don't use this 0.7. Use 0.6.8. That's my advanced advice here. So because otherwise, basically, you will have a bad time. Right now, it's like gonna make it feel like the language is, I don't know, completely unstable. But it's just like this. It's a very temporary thing. It will be stable soon. But I just wanted to get all these changes out of the. Um, yeah. Okay. So right. 0.6.8 prints warnings from the standard library. Yeah, that's unfortunate. Maybe I should make a release that kind of fixes that. You could do it yourself, right? You can actually do it yourself if you want to. It's just one file that's just remove the deprecator from there, and everything is fine. And you can also run. There is like this option which is called deprecated silence deprecation, I think. So if you run silence deprecation on 0.6.8, you will have a good time. So it's a use that. That's my suggestion. Just silence it. That's best. Anything else? So that was a good question. So use 0.6.8 and silence deprecation if you have any problems with deprecations. You can run that later. It doesn't matter. Like if you see something in the standard library, you can either kill that manually. That's fine to edit the standard library. Please do. And if you find something, if you add something cool, then consider sharing it back with a PR. But otherwise, you can just remove those deprecation notes. It's like, go ahead, please. Don't think of it as like as something set. It's like right now that's the best thing you can do is probably to remove the deprecation notices on those things in the standard library. But don't use 0.7 unless you want to give feedback on the syntax. So if you want to give feedbacks on this syntax, absolutely, like grab 0.7 and write some things, like get a feeling for it, and then you can have some opinions on it. It's very hard to okay, let me not rant about it, but just discuss it. It's very hard to figure out a good syntax. It's just like you can bike shed about it for an insane amount of time, but nothing really. Like after you have some candidates, writing some sample code that really tries it out, that's going to reveal much more, really, for you, for how it feels. It's like, at least for me, you can type something and it's like, Does it feel right to type this? Does it feel like, what am I typing? This is kind of weird. You kind of get those feelings as you are using features, really, and you can't really predict what it'll feel like. Um, like if you use something very often, you will get one feeling, and if it's like somewhat rare, you will get a different feeling. If you have the feature all over your code, you will have different demands compared to when it's used sometimes. Um, so I think you all find that if you try it out, just write some sample code, you can kind of get a feel for if something is good or bad much easier than just thinking about it and trying things that looks good, because what looks good is rarely good. It's not the one that it's not the syntax I end up using. um, like but you have to, like, at least for me, that's the truth. I mean, I'm like not um, like the generic syntax, for example. We try a lot of those, and definitely I would say the braces was not my first or second or even third or even fourth choice, but I think it kind of works now when I've used it a lot. When are those name changes you mentioned going into master? I want to try. Okay, I actually haven't implemented them yet. I implemented I worked on the IntelliJ plugin to kind of get it to look right, because I wasn't sure. So I wanted to see like how does it look like if I do it. So it's not in master yet. I might want to think about it a little more, because it also feels weird to me. Let me just state that I never feel comfortable with things. Alias, for example, that one was like, I even had a poll going on the Discord just to get more of a feeling if people were accepting it, even though like they didn't. I actually looked at Alias very early on, and I thought this looks bad, so I removed it and changed it to def, because I felt it was too alien um, to use. And now it kind of come full circle when I'm back. Like, okay, yeah, let's use alias after all. And uh, so what changed during this time was not just I changed my mind, but also there were some subtle things, and I would like to share those. So when we had alias from the beginning, we had this, right? But we also had this distinct, yeah. And now you might understand, perhaps, why this felt a little weird. This was not just making an alias, it was making a distinct thing that was a type. Now that but I had this, right? So I started with this. Actually, I had define, and then I reduced that to def, and then I was like, I use distinct all the time. Let's move that one into something separate, and then we can just have this. And I know some people said like, we don't really need, why do you put this, why do you make this distinct here? But it was, I feel it was absolutely the right decision, because having distinct here was very subtle, you might overlook it, even though the semantics would like be radically different. So by having it there, I could then later make it like do interfaces like this. So suddenly that syntax made sense. And then I was able to do like inline at that. And that was just because I would moved away from def, which would not have worked. It would not have worked with the def. So once I'm here, now look, def is like, it's always very simple. So then suddenly, yeah, alias makes sense. Because now we have alias as apart from this. And now we have distinct and alias, then maybe we can do typedef. So it's kind of the one change alters the others, and then we kind of go full circle and come back to something that's different from the original thoughts and designs. And at least for me, that's just a natural progression. It's just like when you program something and then you have one kind of design for example, like how does the type system work in this case of the C3 compiler, and then eventually kind of, well, now we have all these types and works like this. Maybe if we change the type system now, we could get a much simpler model. But it's a simpler model now because we've added things that made the old model more complex, that didn't fit the old model. And the same thing happens with the language, because we've added a lot of features in 0.6 and 0.5. The interfaces, for example, doing more things with distinct. We have adding the inline. We also add the inline to the enums. With all of these changes, everything kind of just shifts a little gradually, and then we end up with something that so that the old syntax doesn't quite fit. And the change here with optional is also like a very, 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 very strongly that way. Because why did I have this syntax? Well, because it used to be kind of a struct that you returned. Actually, it was a struct, which contained first an identifier, which said what type it was, and the other one was the payload, so you can actually send data. But then, so then it was like completely different from an optional. It was like actually it was called failable, and it was more heavyweight than the current optional. So it was absolutely not an optional. And then I made, I think I don't remember if it was 0.4 or 0.5, that made this whole change to say like, okay, we're going to refocus this and make it simpler, and let's remove the payload and call it optional, so people use that where they would return an optional. And then finally, the final twist here now, that you continue and kind of remove it. It's not even a type, it's just like this. It's just an optional, and it has some definitions on what this extra payload can be, and there's just one type that can be stored inside as the excuse. And now suddenly it makes sense to change it to a question mark. And also we should know that it used to be like, if you wanted, right now it's like if I have this and want to send this, an IOUF like this, right? Put there, you have the question mark, but it used to be like this, and this was like this, right? So they were perfectly matching. And then I changed this to that in order to work better with this syntax. So now we're kind of not matching, but now we're matching again. So it's kind of step by step, they kind of move around and try to fit each other. Okay, so why does like inline enum versus I need to catch up with enums inline enum versus enum. So in enum is inline enum is just it's an enum. Just I call it inline enums because it has a field which can be the ordinal or it can be the um, one of the associated values, and it will implicitly convert to that value if it's possible, or if it's no if it's needed. So that's all. That's it. Just works as just a distinct type, which kind of distinct type can be inline, so it can convert to its underlying value. And a struct can be have an inline field, which has to be the first field, so which it can convert to. So the inline thing is like for every structs for enums uh, for distinct types, not for unions. Although there is something called a transparent union in GCC. That is basically what an inline union could be. So we'll see. Um, I don't think anything else would be candidate for inline. Um, yeah, no. Okay. So why does inline enum exist? So the main use for that is to model actually C enums, but without making it just useful for C for handling C enums. We can use it for other things as well. So you can maybe you have a list of strings and you want to be able to enumerate those, then you can make an enumeration that has an associated value, which is those which would be like these strings. You could have the ordinal and so on, rearrange them, but you can also get the string just as a string. I don't know. Some people have been using that for different things, other things than I thought they would use it for. So that's a good sign. If people are using your feature for things that you didn't envision that they would, then probably that feature is not enough flexibility to actually be useful, um, and should stay in the language if they can use it. Sometimes you have to remove it because they use it for things that you really don't want them to use it for. It was kind of cool when people used the string eval for that to kind of write any sort of code using compiled as strings, but it was like also very scary. It was just it was like flashbacks to Ruby, Ruby meta programming. It was not a good thing. Not a good thing. Right. So, are there any other questions? So feel free to ask them now. Otherwise, I guess I can say goodbye. But yeah, maybe you have some questions. So if you want to, okay, intelligence-driven development. Yeah, but actually that's well, you don't need to use intelligence. You just need to have like a if you want to create the language, like you can't really like it's the great thing is like get some simple way to syntax highlight your language. Just highlighting your keywords is probably enough. Once you have that, you write down the samples of your language, like small code examples. They don't have to compile. And then you can quickly you can see, oh, that was a bit annoying to write that. That I what was I thinking about with this? Oh, that one shouldn't go in. Oh, and that one's kind of ambiguous. So even if you don't write a grammar, you don't have a parser, you don't have a lexer, just writing those examples, which is kind of really not funny, fun to do, will give you like first of all you have like samples of the language, which you can use for documentation later. You can kind of see your different. You can try out like do all the statements. Like here's the if statement, while, loops, function call, all of these. You can see what your language will look like, and you can iterate that. Like, no, I don't want. I want this feature. Just write that, like pretend it's there, right? And then you can remove features. It's like this almost zero cost. And if you want to change some keyword, if you have just, you're just highlighting the keywords, just add the keyword or remove that keyword is done. So and then you type it into a whatever editor you have with those keywords highlighting it, and just like it feels like you have the language like really professional. You just really need the keyword highlighting, and it feels like, yeah, it's my language. If it feels good, now you know that this kind of feels good. I want to see this happen. And you'll eventually reach that kind of that point, but it will look very different from what you set up. Or if you think of some feature and then you like think of it like for a real long time, and but you never really try it out, and then you implement it, put all that work, but you never thought to kind of just write it down. And you'll discover that what you thought was good was you could have solved that by writing 3 lines of code to see if it was good, like in context with everything else. But you didn't, so now you spent all that time, and then maybe you don't want to remove that feature because, by God, you spend so much time adding it. That's like people who are coding and they make like all these features for things that they anticipate that some time in the future ask for, but they don't test that and they are making assumptions. And then they kind of want to push that live and so on. And they don't want to change that or throw anything away because, well, maybe we'll use that later, but they didn't test it and it's untested. So when you actually try to use it later, it doesn't work. I've seen that so many times. So and a similar thing happens, with languages when you try to implement too much too soon. I mean, even writing down the grammar for a language is an investment in time, because you get like, oh no, there are some ambiguities. I have to rephrase this and write it differently. Otherwise, it will be no the recursive blah blah will like it will not understand it. What priorities I want and so on. So it's like it's not. I'm pretty used to Jack to using bison and so on, but I get I sometimes get or often when I change the syntax get shift and reduce errors that I have to fix. So it would be much easier for me to just change. If I want to test something, I don't write the grammar for it. I don't do that. Just type out the code and then see how it looks like. That's the best. Okay. Twitch them all, a great technique. I never thought of it. I tried writing my own mini language for a domain, and I got so bogged down in lecture parts. Yes, that absolutely happens. That happen to me. I was like, let's make a language. This was way back. Okay, so it kind of I wrote down some things, I guess, some examples, but not much. And then I was like, oh, I have to go write the lecture and parsers. But that's just you want to jump to the part where you can use your language, so you tend to try to rush through the lecture and parser and everything. But The truth is, you can already try your language from the start. You just type it up because in the end, the output is not the important thing. What is important is the feeling when you type the code, right? It's never the like C code is C code if if you don't have a C compiler. Even if it's not running a C compiler, it's still C. Yeah, C source file if you write C. And so will your language source files be your language even if you don't have a compiler for it. Um, yeah, output for a complex. And then there's the problem with something else that's actually a problem. I don't know how to really overcome it in a good way. Is writing APIs for standard library because you really want to have APIs that are kind of use case driven. So if you look at something like Raylib, that one is super use case driven. It's like, yeah, I needed this thing, so that function was added. And then you have other things like, let's say, the Java standard library, which was one of the first really big, publicly easily accessible standard libraries, which has all these like you get to load from a file. You first get a file, and then you put that file in a file input stream, and then you put the file input stream in a buffer stream, and then you kind of load data to some bytes, or you have some other stream that perhaps can load those bytes, something like that. And finally, maybe you have like a string reader-ish thing. Those readers were the extra thing that would be like always more safe to use that because they understand UTF-16. Well, anyway, the readers, and then you kind of in the end, after invoking all these steps, you kind of get your string, which was the data you wanted to load in the first place. And all those steps are like almost always I just want to get like, here's the file, give me the text. Here's the file, give me the binary data. And the Java API is like, no, you have to go through all these steps just in case someone wants something. And they could have made this super simple utility thing that was like would be like file load, and you would get the data. And that would do all those things, but it was like the API would be very, very convenient. And that's what we ended up to back in my days at On Game. We had ended up having like some like extras classes that we had just had static method and had some of those utilities. Those are really useful to write succinct code because otherwise you would just, oh, I want to load a file, and then you do start, having that file input stream and so on. The same for writing, of course. And I mean, the similar thing is happening to people using lib. I mean, people who use Java, they kind of tend to rewrite those because any code sample, we cannot assume that there is such a function that already does all this. And so people tend to reinvent this thing unless they are using some very well-known library that already has the feature. But due to Java, the Java standard library lacking this, means that everyone learning Java and trying to load a file will feel that loading a file is a hard thing to do. And there's a similar thing going on in libc land, where if you learn C and then like there are no dynamic strings, no dynamic arrays, and there are dynamic arrays and dynamic strings implemented by various libraries, but because those are not standard in libc, people instead would show how you do it by having a buffer and then resizing that buffer and over again several times. And then people think that that's the way you're supposed to do it, and then they copy that and they have a bad time. Just as they copy these like many Java steps, and then like, oh, here's this like whatever framework, it just loads the files for me. Whoa, how exciting and fresh and simple. It's just like, yeah, it's simple because you didn't write um, that helper function. You didn't know you're permitted to write a helper function, but you are. And so, kind of, for a standard library, it would be nice for once to have a standard library that actually does that, like be friendly. The scripting languages tend to have better APIs in that way. They tend to be like, okay, let's help people actually get things done instead of, oh, let them customize this 1,000 ways. You can still have the customize, but damn it, give the way to kind of make it easy out of the gates. But that's hard to do because, like, unless you know the domain, unless you have a problem, it's kind of hard to know what you want the API to be. So that's actually harder, I think, than um, testing out your language design. Because testing out your language design is more of a, you can have small snippets, and from the small snippets of code, you can kind of get the feeling for it, for a lot of things anyway. But I guess in the if you really want to get down to it, it would be best if you had a big project, and it's not, that's where we talk about dog fooding. But I'm also always saying that a compiler is like one of the worst projects that you can use to test if a language is good or not, because of in a compiler, if you do it right, you can ignore memory management, and you have this batch thing that you just run and then it's done. Whereas in a game, you kind of have things and you have these state transitions, and it has to run all the time. And this is so much, so much more, so much, so very different from a compiler, a batch compiler. And then we have like a web backend, which has again different constraints with it, because now we're talking about like a lot of problems around threading, connecting to resources that might be blocking. So all of these are quite different domains. Those are more useful to kind of test for. Okay, so yeah, uh, yeah. You want to create. We want to write against this imaginary API. Yes, but it means the problem is that you need to have the projects that are supposed to use them, rather than anticipating what people might need to call. So that's my problem. It's like making assumptions. So many standard libraries are making assumptions about what the problem is that people will have with a standard library, what they are trying to solve. Um, so in the case of, for example, Java, what they're thinking that people will want to try to solve is like taking files and reading parts of it and then translating it on the fly and doing things to it. And yes, one thing, some things are actually like that. You can do, for example, you can have a stream or something and some data, and you compress it as it goes through this pipe. But so they are thinking of the Java use case is really like there's a pipe of data coming from some input stream that is like giving you data, and then you take that on the fly and change it. But the lot of cases with a file, you can grab everything and then you do your transformation on what's already in memory, rather than having it as it flies by, basically. So I appreciate when people are writing stuff and I can see where were their pain points, like what, and if they report them, that's great. And something like if someone is writing something and they find that they need some sorry about that, some helper method, then do contribute those helper methods to the standard library, because they're probably very useful for others as well. Like, not necessarily. I mean, you can probably have like, if you're writing something very special, then of course not. But otherwise, let's get that into the, like, these helper things are good, generally good. Okay. Now I spoke another. Yeah, mutex locks, a trailing body macro, super handy. Yes, I saw that one. Yes, that should probably be in. So we just contribute stuff like that. I don't have time to kind of create all those. I like when I use it, I find, oh, this needs something. I can put that in the standard library, but I need some help. Like I can't program everything. I don't have time to write all the different programs that will give me make it possible for me to give feedback to all of the different domains. It's just not possible. Time, even if I would have done this full time, I would, it's too much work to write the standard library on your own, a good one anyway. Like I could take, some standard library, let's copy some other standard library, but since they all kind of suck, um, various ways, at least those that are more low level, there is nothing that you want to really port. Maybe there are good libraries that people can really, if there are nice C libraries, they wanted to kind of, and I wanted to have that functionality in C3, definitely tell me, and I try to do that. So, is the standard library contributors that are you mostly looking for? I think the standard library would make a super huge impact if you are able to add functionality. Like, the language is mostly like it is, right? And there is not much compiler. I mean, the compiler is not free. It's not the problem. Um, I would say that what we need to make a language great is when you can solve problems with the language. And if with C you have already the luxury of having a lot of projects that are written in C that you can kind of look at and pull in. But if you have a new language, you really want the language to have a standard library so you can solve things easily, give you a good experience, really. I would actually love to have a graphics, an official graphics library into the standard library, just to have something that so people could just rely on that. But I think that's might be um, an impossible thing to do, because for a graphics library, people want some very different needs, very different things. So might not be not be possible, but uh, at least everything that isn't graphics, maybe can draw the line doing HTTPS because of all the crypto needed. Since those are certificates and stuff like that, because there's just so much stuff in there. But others, okay. So what you say? So let me see here. The Go standard library is sometimes referenced as an example. It's not that ideal in some parts, but some helpful use cases in there. Yes, I think there are good use cases in. Probably, I mean, I'm more familiar with the Ruby standard library, but also probably in Python, um, because those scripting languages are not like, oh, let's have this fine grained control. That's not the thing you want to solve a problem. Not model the best way of doing things. So there are two things you want to do. You want to make them productive and give people control. And for the things that you don't care about, you just want to be productive. For the things you really care about, you want control. So both are important, obviously, but giving people this quick win makes them feel comfortable with language. It gives them self confidence that they can do things. It also makes it easier to just do these kind of throwaway solutions or prototyping if you can do it simply. It doesn't have to be the most efficient way. For example, the hash map, people are using the hash map. It is not, I mean, the hash map can be very, very different, differently implemented, and they have different performance characteristics. But most of the time, you don't have the problem with like it being not optimal enough. It's just you just need some hash map, and there's a lot of other cases like that. You don't need the perfect solution; you just need a good solution that make you kind of take the next step, so you can continue working on it, seeing your concept come to life, and then refactor it later. Threading is quite hard to do at the moment. Was doing some experiment, but very early days. Yes. Rexham's Olivec. I don't know about the Olivec project. That didn't. Is that which one is that? I looked at some of the those projects, but not all of them. Threading is quite hard to do at the moment, yes, and threading is difficult because of there are so many different ways to kind of do thread pools, where Java has a bunch of them with very different characteristics. Are the Clay library are what's the question? Is that the question to Jamal or someone else? Oh, I just saw here. There's like the question about mean like the Clay library. Anyway, yeah, I'm probably gonna shut down here. It's like it's getting late. I'm going up fairly early tomorrow. But I thank you for listening, and we'll see where the syntax changes in 0.7 will take us. Hopefully, everything can solidify by 0. By for 0.7 by yeah, in a week or so. And then after once 0.7 is released, we're going to go into 1 year of backwards compatibility. So then it's going to be fine to write all sorts of programs in 0.7. And then we'll end up evaluating the syntax for 0.8 and also those things that have been removed, if they need to have a comeback or something. We'll see. You know, I never say never to these things, because you don't know if some feature goes away or something new comes, maybe things change. But my ambition is to make this language smaller, as small as possible, without removing the what's important. You know, and I feel like now we're reaching a point where we kind of removed a lot of unnecessary things, and we're mostly with the important things. We have them, and we can kind of extend in some capabilities, uh, but we're not making it more complex and has more features that people have to kind of learn. It's getting a little smaller. I don't want people to feel that, oh, this is a hard language to learn. It has a lot of parts. There are different things that kind of cause people to feel it's complex. Is one, like lack of familiarity. If the understand library, if that one is complex, people feel that the language is complex. But also, you know, the more things, when people discover new features late, then they lose a little confidence in themselves and in the language, I think. Okay, but that's it. Thank you for watching. I'll put this on YouTube, I think, and but unfortunately, your stream chat here will be gone. But I read it from the chat, all of it. Okay, thank you. Have a nice evening and have a good weekend, everyone.